Routine tissue processing involves the preparation of tissues for microscopic study. It is the series of processes and procedures starting with fixation, dehydration, clearing, infiltration, embedding, trimming, sectioning, staining, mounting, and lastly, labeling. To start off, fixation is the most crucial part of routine tissue processing since it preserves the morphological and chemical integrity of the cell. It also hardens and preserves the tissue for further handling. The tissue must be cut in a square millimeter thickness. This is to ensure the containment of it in the tissue cassette. The tissue cassette is then submerged in a fixative solution, 10% neutral buffered formalin, and left to fix for 3 to 24 hours. This is the process of the removal of intracellular and extracellular water from the tissue. It is achieved by 3 or 5 sets of dehydrating agents. Ascending grades of alcohol is used from 70%, then 80%, then 95% alcohol for 30 minutes in each. This step is also known as the de-alcoholization, which removes the dehydrating agent and replacing it with a clearing agent, which results in a translucent tissue, increasing its refractive index. In this step, 2 to 3 solutions or sets of silane clearing agent is used.
Dehydration and clearing are done nowadays with the help of Autotechnicon.
After clearing, the tissue can now be infiltrated with a suitable histological wax. Over many years, the paraffin wax-based histological waxes are the most popular. A typical wax is liquid at 60 degrees Celsius and can be infiltrated into tissue at this temperature, then allowed to cool to 20 degrees Celsius where it solidifies to a consistency that allows sections to be constantly cut. Now that the specimen is thoroughly infiltrated with wax, it must be formed into a block which can be clamped into a microtome for section cutting. This step is carried out using an embedding center where a mold is filled with molten wax and the specimen placed into it. The specimen is very carefully oriented in the mold because its placement will determine the plane of section. A cassette is placed on top of the mold, topped up with more wax, and the whole thing is placed on a cold plate to solidify. When this is completed, the block with its attached cassette can be removed from the mold and is ready for microtomy. Before the sectioning of the tissue, trimming is needed to expose the tissue piece within the paraffin wax for cutting. The block is fixed in the chunk of the microtome and the paraffin is cut till the tissue is fully exposed. Adequate caution should be taken not to overcut tissue as this may produce various artifactual changes.
Once the tissues have been embedded, they are cut into thin sections ready to be placed on a slide. This is done with the microtome, an apparatus for feeding the blocks past an ultra-sharp plate with micron-level precision. Paraffin blocks can be sectioned with high-carbon steel blades. Plastic blocks are sectioned with glass or diamond knives. A glass knife can section down to about 0.1 micron. Ultra-thin sections for electron microscopy are best done with a diamond knife. As sections are cut, they are floated on a warm water bath to smooth out any wrinkles. They are then picked up on a glass microscope slide. The glass slides are then heated in a warm oven for about 15 minutes to help the section adhere to the slide. In order to get the paraffin wax out of the tissue and permit water-soluble dyes to penetrate the parts, the slides are then deparaffinized by running them through silenes or substitutes to alcohols to water before any staining can be performed. There are no stains that can be used on paraffin-containing tissues. A number of dyes selected for their ability to stain different cellular components of tissue are used in the staining process. Hematoxylin and eosin stain is the routine stain, while the other stains are referred to as special stains because according to their diagnostic needs, they are used in particular circumstances. In order to preserve and support a stain section for light microscopy, it is mounted on a clear glass slide and covered with a thin glass cover slip. Slide and cover slip must be clear of optical distortions to avoid viewing artifacts. Cover slip is adhered to the slide using a mounting medium. There are AKIS-based mounting media available that allow tissues to be mounted directly from the staining process. However, in such mountants, the water solubility of certain stains enables them to bleed and/or fade, requiring the use of resinous mounting media. Segment must be dehydrated again and cleared first to use a non-aqueous mountant. Any water brought over to the mounting stage will show up as bubbles or vacuole-like structures, as the water droplets aggregate and distort the tissue.
The last step in tissue processing is labeling. Labeling is the process of giving the specimen a specific identification number or code for easier identification. The label should have an accession code or the type of specimen, the year it was received, and the specimen number.